This algebraic fraction question is worth 6 marks, and it's one of the trickier ones. Because you're adding the fractions together, um, whenever you add fractions, you need to be working in a common denominator. And so the first question really is, how are you going to get a common denominator of x minus 1 and x squared plus 3x minus 4? Well, maybe before I go through the example, I should just explain how that generally works. Suppose we have, let's say, 2 over 7 plus, I'm just thinking of numbers, actually let's throw in some algebra anyway, let's say 3x over 35. Now, in order to, if you were going to work this out, obviously you'd have to work in the same denominator, so you'd say the lowest common denominator is 7 and 35. Well, 35 is 5 times 7, so you just multiply this one by 5, top and bottom, and turn 2 over 7 into 10 over 35. So 10 over 35 is the same fraction as 2 over 7. Then if you're adding, say, 10 over 35 to 3x over 35, then you simply add the numerators and put it as one fraction, 10 plus 30x, all over 35. That's a simpler example of the same principle we need to apply here. In order to work out the lowest common denominator of x minus 1 and x squared plus 3x plus 4, you have to take account of the fact that these questions generally have a fixed pattern. You can expect that x squared plus 3x plus minus 4 will have x minus 1 as one of its factors. So x minus 1 will go into this in the same way that 7 goes into 35. So you can just multiply this fraction by its other factor. In this case, we multiply top and bottom by 5 to make it compatible. If we multiply x minus 1 by the other factor of this on top and bottom, then we'll be able to add them in the same way. So it's a guarantee almost that x squared plus 3x minus 4 is has one of the factors as being, why am I putting brackets there? Ignore the bracket, let's get rid of it. So x squared minus 3x plus 3x minus 4, if we factorize it, it's a monic quadratic. That means that it's just x squared and not 2x squared or minus 5x squared or anything like that. So whenever you have x squared by itself, you're looking for two numbers which multiply to make negative 4 and add to make 3. So the two numbers which multiply to make negative 4 are either going to be 2 and 2, 1 being positive, 1 being negative, or 4 and 1. So we need to think of ways in which 2 and negative 2, or obviously, well, yeah, swap around is still negative 2 or 2, or either 4 and 1, 4 and negative 1, or negative 4 and 1 add together to make 3. And you should have picked up that one of those options was this. And of course, we knew that x minus 1 was going to be a factor anyway. So this is x plus 4 over x minus 1. Now, let's find some space. If we now rewrite this as 2 over x minus 1 plus x minus 11 over x minus 1 times x plus 4, then the strategy takes the shape. So the first thing you need to do in this type of question is factorize the quadratic. You can expect to have to do that in any question of this type when you get an algebraic fraction question near the end of the paper. So now we can see, in the same way as with 7 and 35, to multiply this denominator to get this one, we need to multiply it by x plus 4. So to keep the fraction constant, we multiply top and bottom by x plus 4. So this fraction becomes 2 over x plus 4, sorry, 2 times x plus 4 over x minus 1 times x plus 4. And to that we're going to add x minus 11. And as we did with the 7s and 35s, once we had the same denominator, we could just make that equal to one big thing. I'm going to have to, there's going to be a bit of a messy working out, apologies. So we can just combine the top over the denominator, and we get 2 lots of x plus 4 plus x minus 11. I'll put that in brackets because if it said minus, we'd have to remember to make it minus x and plus 11, but that would just be a rather nasty question. Now, 2 times x plus 4 is obviously 2x plus 8. If we add x, we get 3x plus 8. If we subtract 11, we get 3x minus 3. And this is important. That now becomes 3x minus 3 over x minus 1, x plus 4. And I'm keeping the denominator factorized because If the top can be factorized, it may cancel with the bottom, as is often the case in this type of question. And you'll notice it's worth 6 marks, which is a hint, because 6 marks suggests there's going to be another stage. We've got 1, 2, 3, 4 stages at the moment. The next stage is to say that the top is equal to 3 brackets x minus 1 over x minus 1, x plus 4. And having factorized top and bottom, we can now see that x minus 1 is a common factor and it cancels, leaving us with our final answer, which I'll put in red, 3 over x plus 4. So just thinking through the stages, you've factorized the quadratic, you then rewrite both fractions over the same denominator, usually because this one is one of the factors of the quadratic, so you just have to find the other factor and then multiply this one by that factor top and bottom. You combine the numerators, you simplify it down, you factorize if you can, and if one of the factors cancels with the denominator, then you cancel that out, and that's how you're left with your final answer.